Hi, welcome to Venkatvarma Chemistry YouTube channel. I am Venkatvarma, your host and chemistry enthusiast. We are here to make JEE NEET preparation easier and more effective, short and easy to understand videos. In this session, we are going to learn ETHERS in one shot, complete ETHERS in one shot. Let's start our session, ETHERS. The first one is general methods of preparation of ethers from alcohols. General methods of preparation of alcohols. General methods of preparation of ethers from alcohols. The first method is dehydration of alcohols. Dehydration of alcohols. What is the reagent used? For the dehydration, concentrated sulfuric acid is used. What is the reagent used? Concentrated sulfuric acid. Concentrated sulfuric acid is used. See, at concentration of the sulfuric acid from alcohol to ether using concentrated H2SO4 at a low temperature. The temperature is 140 degrees Celsius. The temperature is 140 degrees Celsius to give the ether. See, if alcohols at high temperature, in presence of concentrated H2SO4, it gives alkenes. Yes. See, at low temperature to give the ethers, at high temperature means at 170 degrees Celsius, it gives alkenes. Yes. Now, we are going to discuss what is the mechanism happens in alcohol to ether. See, look at for the mechanism. See, alcohol ROH at low temperature. Low temperature means at 140 degrees Celsius. At 140 degrees Celsius, the H plus attacks over an oxygen to form a ROH, means ROH2. See, the H2O is an easily living group. Another mole of alcohol attacks over an R to form a C. It loses water. See, it loses water. The another mole of ether attacks over an R. What is the type of reaction? It undergoes SN2 reaction mechanism. See, to form a, so the proton will eliminated in the form of H plus to form a ROR to form a ether. Yes. At high temperature, what happened? See, at high temperature to form a H plus attacks over on ROH2 plus to form a carbocation. After that, elimination is happen to form a alkene. This is for the dehydration of alcohols. Have a look for example. See, C2H5OH. C2H5OH at concentrated sulfuric acid at 140 degrees Celsius. What happened? In the presence of 140 degrees Celsius means at a low temperature. So at low temperature, so what happened? H plus attacks S to form C2H5OH plus S. Eliminate the water. So eliminate the water. Another mole of alcohol attacks over on C2H5 to form a C2H5 O and C2H5. Oxygen, it is unstable, taking the electron from hydrogen to form a H plus, to form a C2H5O and C2H5. It is a ether. It is a ether. Here what? Deprotonation, removal of proton. Removal of proton. Yes, this is for dehydration of alcohol. This is the first method. Now coming to what is the second method. What is the second method? Have a look for second method from alkyl halides. See, alkyl halides in presence of Rx. Alkyl halide means Rx in presence of Ag2O, silver oxide. See, dry silver oxide to form a ether, ROR plus 2AgX. Have a look for example. See, 2 moles of methyl bromide in presence of dry silver oxide, dry Ag2O to form a CH3. It is a dimethyl ether and silver bromide. It is from alkyl halide. Let's move on next method from diazomethane. See, from diazomethane or phenol. Diazomethyl or from phenol. See, I am taking phenol or alcohol. See, I am taking alcohol. See, CH3, CH2OH in presence of diazomethane. Diazomethane means CH2N2. It is a diazomethane in presence of HbF4. In presence of HbF4, it gives what? CH3, CH2O, CH3. It is a diethyl ether. I am taking phenol. See, phenol in presence of diazomethane. In presence of HbF4, it gives anisole. Have a look for this anisole. Benzene with a OCH3 group to eliminate the nitrogen. Yes, this is a anisole. Methoxybenzene is a anisole. Benzene with the OCH3 group is a anisole. Yes, this is the third method. Now fourth method, the very important method, Williamson ether synthesis. It is very important for objective oriented. See, Williamson ether synthesis. What is Williamson synthesis? So alkyl halide. See, alkyl halide. Its formula Rx in presence of sodium alkoxide. Yes, sodium alkoxide. See, in presence of dry ether. So what happened? See, I am taking first example. It gives ether. So what happened actually? See, Rx in presence of RONA. See, here RO minus Na plus. So X is leaving group. Means the O minus attacks over R to form a ROR. Yes, and NaX. What mechanism is involved in this nucleophilic substitution reaction? That is the SN2 mechanism. Yes. See, in this SN2 mechanism, what happened? See, what is a reactivity? So primary alkyl halide. See, primary alkyl halide and secondary alkyl halide, tertiary alkyl halide. Which is more reactive? See, primary is more than secondary than tertiary alkyl halide. It is a reactivity of alkyl halide. The primary alkylides are more reactive. Let's take an example. See, methyl chloride. Have a look for methyl chloride. See, methyl chloride CH3Cl. Yes, in presence of in presence of, see, tertiary butyl CH3 CH3O Na, the tertiary butyl alkoxide. Tertiary butyl alkoxide. It is a minus. It is a plus. What happened in this? What happened in this case? Here also nucleophilic substitution reaction. X is leaving group. The O minus attacks on CH3 to form a what? CH3O CH3 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 CH3. Yes, it is a ether. It is a ether. Yes. So let's take this example. For example, if we are taking tertiary alkyl halide, what happened? Tertiary alkyl halide, it fails to give the ether. Tertiary alkyl halide, it does not give the ether, it gives alkenes. What happened? Elimination happened. E2 elimination is happened. See, I am taking example. See, tertiary butyl alkyl, see, tertiary butyl CH3 Cl in presence of methoxide alkoxide. Yes, what happened in this case? So the leaving group chlorine, it is a alpha position, it is a beta, it is a beta, it is a beta. So how many betas? 3 betas. These are same environment, the same beta environment. What happened? So here Cl is eliminated, carbocation is formed. When carbocation is formed, say I am writing CH3 like this. See, to form a carbocation is formed, it abstract the proton, to form a alkene CH3, C double bond CH2, C double bond CH2 and CH3. It form a alkene. The compound name is a isobutene. Yes, this is the important case. If Williamson ether synthesis, we are taking tertiary alkyl halide to give the alkene system. What happened? Elimination is happening. See, elimination is happening. Yes. Now we are looking for some questions. See, have a look for example. See, alkyl halide and phenoxide. This is alkyl halide and phenoxide. What happened? See, sodium alkoxide, sulfinoxide ion, the bromine is eliminated. What happened to form a, see, this is the product. CH2, CH3 and CH3. This is the product. Have a look for this example. Alkoxide with bromobenzene. So alkoxide, bromobenzene. Alkoxide with bromobenzene. Aryl halide. So aryl halide, see, aryl halide not used for the Williamson ether synthesis. What is the reason? Because of their low reactivity towards the nucleophilic substitution reaction. So here resonance is possible. See, resonance is possible means it is not formed the product with aryl halide. Aryl halide and vinyl halide also. Vinyl halide, aryl halide, they are resonance stabilized, so they do not form the product. Aryl halide cannot use it for the Williamson ether synthesis. Yes, have a look for next example. See, if A is a alkoxide ion, means salt. B is the alkyl halide. So what is the AB? To find the AB. For example, A is salt, so B is the alkyl halide. What is the salt? What is the alkyl halide? So what are the possible? C phenoxide, C PHO, yes, and CH3X. When halide in the form of X minus, the O minus attacks on methyl group. Yes, is it possible? Yes, is it possible? It is a PH PHO plus CH3X. This is the A, this is the B. So another possibility, I am writing this possibility, I am writing in the another possible C, I am writing another possible CH3O and PHX when in this halide involve the resonance. To form a alkoxide, it is not possible to form the product. So it involved resonance, it could not form the product. It is not possible. Which is possible? This is the possibility of the reaction. Now coming to this one, A, B to give. So I am writing possibilities. First of all, I am writing possibilities. So O, it is a O minus and a CH3Cl. So Cl in the form of Cl eliminated, the O minus attacks on CH3. Is it possible? Is it possible? Yes, is it possible? Now coming to next possibility. See, this is the possibility. X means halide and CH3O minus. So CH3O minus, here this is the braided head carbon. So the braided head carbon not possible to attack the methoxide ion. O minus is not attack the braided carbon. It is not possible. Which is possible? This is the possible. This is salt. This is the alkyl halide. Yes. See, have a look for next example. See, look for this. See, PHO and CH2 double bond CH2. PHO means this is a PHO. So it is a vinyl halide. It is a vinyl halide. In the vinyl halide, it involved resonance. Yes, it involved the resonance. So involved the resonance. It could not attack over on the carbon. So it is not possible. So no reaction. Yes, because of resonance stabilize. So I am taking another one. CH2 double bond CHO minus and PHX. So here also not possible because of resonance stabilize. So no reaction. Have a look for this one. So A, and what is salt? What is alkyl halide? So here symmetrical ether is there. So we are taking what? See, it is alkoxide. Now is alkyl halide? Yes. Is it possible? Yes, it is possible. This is the possible structure. CH3, CH2, CH2, CH3, CH2, CH2X. So it is a possible structure. A is salt, B is a alkyl halide. See, have a look for next one. See, phenol with sodium hydroxide. What happened? Phenol with sodium hydroxide, it is a phenoxide ion is formed. Sodium phenoxide is formed. Sodium phenoxide with alkyl halide. What happened? Alkyl halide to form a OR. Yes, it is a ether. So Williamson synthesis not applicable for the both phenyl group and tertiary groups, vinyl groups. See, important point. See, Williamson ether synthesis is not applicable for phenyl or tertiary or vinyl groups. Yes. See, have a look for next properties of ether. The properties of ether, the first one is reaction with hydrogen halide. Reaction with hydrogen halide with ether. What happens? See, properties of ether. Properties of ether. See, ether. ROR. ROR in presence of HX, hydrogen halide. It's H plus X minus. See, what happened in the presence of H plus? In the presence of H plus, it attacks on oxygen atom. Yes, it attacks on oxygen atom to getting positive charge. Again, X minus, X minus, X minus. What happened in the X minus? C. X minus to form a alkyl halide with the alcohol. Alkyl halide with the alcohol. Yes, halide and alcohol. C. See, when H plus attacks on an oxygen to form a ROH, it is unstable. It is in the form of eliminated ROH. Yes, ROH is the X minus attacks over on R to form a alkyl halide and alcohol. Have a look for important point. So before that, what is a reactivity? What is a reactivity order? So it is a alkyl halide, it is a alcohol. Yes. What is the reactivity of alkyl halide? Hydrogen iodide. Yes. Hydrogen bromide and hydrogen chloride. So which is more reactive? Hydrogen iodide is a more reactivity. See, have a look for if ROR important. So ROR if tertiary or secondary or primary or secondary, R stands for R dash if tertiary or primary, secondary stabilized, primary, secondary stabilized. So it undergoes SN1 reaction. So how to identify when ether undergoes SN1 and SN1 or SN2 by using this trick. Tertiary or primary, secondary resonance stabilized the carbon undergoes SN1 reaction. Yes, if ROR primary or secondary, it undergoes SN2 reaction. Remember these things. ROR tertiary or primary, secondary resonance stabilized, it undergoes SN1. If ROR primary or secondary, it undergoes SN2 reaction. Let's take example. For example, I am taking CH3 O CH2 CH3. So it is a primary. It is also primary. It is a super primary. It is a primary. Carbon attached with only one carbon. What happened? It undergoes what? SN2. It undergoes SN2. S because primary and primary. So in presence of H plus, to form a CH3O CH2 CH3. It is a oxygen plus positive charge. It eliminated in the form of CH2OH plus CH3X in the form of HX to form a CH3 CH2OH and CH3X. This is the product. Yes. Have a look for next example. See, if CH3O CH3 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 in presence of HX, H plus X minus. What is a product? What is a product? It is what type of carbon? It is a primer. It is what type? It is a tertiary. Yes. See, in presence of H plus, in presence of H plus, what happened? CH3 OH plus CH3 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 CH3. Yes, in presence of H plus primary and tertiaries, it undergoes what? X minus, it undergoes SN1. It undergoes SN1. See, it forms CH3 OH. Is it eliminated CH2OH? The X minus attacks on carbon to form a CH3 CH3 CH3. Yes, it undergoes what type of reaction? SN1 reaction. It undergoes SN1 reaction. Yes, it undergoes SN1 reaction. Yes, next move on. See, have a look for next question. Question is pH CH2O CH3 in presence of HX. In presence of HX, what is the product? See, first of all, I am writing H plus. H plus attacks over an oxygen to form a pH CH2O CH3 H. Oxygen getting positive charge. Yes, oxygen getting positive charge, it eliminated in the form of CH3OH. Yes, again this X minus attacks over on, so pH CH2 plus, the X minus attacks over on CH2 to form a pH CH2X. Yes, this is our required. So what is the product? The product is CH3OH plus pH CH2X. This is our product. This is our product. Have a look for next question. Have a look for next question. See. Next is, look at for this question. PHOCH3 with HX, hydrogen halide, H plus X minus. What happened? See, in presence of H plus, so to forming PHOCH3H. Yes. After that, what happened? It took PHOH, the PHOH phenyl with the oxygen could not break because of resonance stabilization. What happened? So in the form of pH, so it form PHOH. Yes, the PHOH, CH3 plus is formed to form a CH3X. The phenyl oxygen could not break. Why? Due to resonance stability. This is the product. PHOH plus CH3X. Yes, have a look for next. The next is reaction with excess of hydrogen halide. What happened in excess of hydrogen halide? See, if R O R is in presence of excess of hydrogen halide. What happened? Hydrogen halide HX. Hydrogen halide. What happened in the presence of excess alkyl, excess HX? What happened? See, look at for reaction. See, to form a, when breaking off, remember breaking of RO bond, it forms X H. It forms X and H to form a what? alkyl halide RX plus RX to form a 2 moles of alkyl halide. See, let's take example CH3 O C CH3 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 excess of HX. Excess of HX. What happened? Very simple. How to write? Easy to weigh, easy to remember. The breaking of carbon and oxygen, keeping the halogen. So breaking of carbon and halogen, keeping the halogen. So keeping H and H. Yes. To form a CH3X. Yes. To form a X CH3 CH3 CH3. This is our product. Yes. Have a look for next reaction. Have a look for next reaction. See pH. Look for the question. pH O CH3 in presence of excess of HX. Excess of HX. What happened? Very oxygen has lone pair of electron. Lone pair of electron. So the breaking of bond, keeping of hydrogen and halogen. Yes, to form a pH OH plus CH3X. CH3X. Yes. See, have a look for next. So, which of the following the major product? Based on this substance, we are taking excess of hydrogen iodide. What is a major product? So, is it possible to break carbon with oxygen? Aryl carbon with oxygen? Not possible. So, which is possible? This is possible. Possible. Yes. So, this is also possible, carbon with oxygen bond. So, I am writing the product. See, I am writing the product. See, have a look for the, it is a OH, H plus, X minus, H plus attacks over here. Yes. What is the next possibility? So, the next possibility is, see, to form a OH, it is a NC isocyanate. What is the, it is CH3 CH3IS iodide. And what is the next possibility? Next possibility is the CH3. What is the major product? This is the major product. Yes. See, have a look for next reactions. Have a look for next reaction. See, have a look for electrophilic aromatic substitution. In electrophilic aromatic substitution, see benzene with C O R. R group is a what? It is a ring activating group. R is a ring activating group. Yes. Plus mesomeric effect. Yes. See, the plus mesomeric effect means the electron density increases. The benzene ring electron density increases. What is the position? Ortho and para position. So it is what? Ortho para directing group. Ortho para directing group. Yes. This carbon undergoes what type of hybridization? It undergoes sp2 hybridization. So the electrophile attacks over an ortho and para position. Yes. Have a look for halogenation. In the halogenation, the bromination reaction. Have a look for the bromination reaction. See, anisole benzene with OCH3. It is the anisole OCH3 bromination Br2 in presence of acetic acid. In presence of acetic acid, ethanolic acid or acetic acid to form a. See, what is the product? See, this is the product. OCH3 and ortho-bromo anisole and para-bromo anisole. Para-bromo anisole. It is the OCH3 with Br. So, which is major? So, the major is para-bromo is the major and ortho-bromo is the minor. It is the 2-nitro anisole. It is the 4-nitro anisole. This is for bromination. Have a look for next reaction, nitration. In nitration, what is electrophile? NO2 plus is a electrophile. See, I am taking the nitration OCH3 in presence of what is a nitrating mixture? Concentrated HNO3 and H2SO4. Concentrated HNO3 H2SO4. It gives what? It gives 2 nitro anisole, 2 nitro anisole and 4 nitro anisole. Yes, 4 nitro anisole. 4 nitro anisole. Yes, which is major? See, 4 nitro anisole. 4 nitro anisole is the major. This is the major. So 2 nitro anisole. See, 2 nitro anisole is the minor product. It is a minor product. It is a major product. Yes. Have a look for next. Friedel-Crafts reaction. In the Friedel-Crafts reactions are two types: Friedel-Crafts alkylation and Friedel-Crafts acylation. See, anisole in presence of methyl chloride in presence of anhydrous AlCl3. In presence of anhydrous AlCl3, it gives what? It is also give ortho and para product CH3. Yes, and product. So OCH3 and CH3. Yes, this is the major, this is the minor product. Have a look for acylation. So what is acylation? See, anisole with acyl chloride CH3COCl in presence of anhydrous AlCl3 in presence of anhydrous AlCl3. It is also give the product like this: orthopara products. Orthopara COCH3 plus. So this is the our products COCH3. It is a Friedel-Crafts alkylation and Friedel-Crafts acylation. See, have a look for question. See, phenol with sodium heated. What happened? Very simple. So it phenol with sodium metal to form a sodium phenoxide. ONA. Yes, it is a sodium phenoxide. What happened? The sodium phenoxide with the methyl chloride CH3Cl. What happened? To form a anisole. OCH3. Again OCH3 in presence of Br2 in presence of ethanolic acid. What happened? To form a para-bromo anisole. Yes, para-bromo anisole. It is a major product. If it is A, it is a B, it is a C. We are taking B in presence of excess of hydrogen iodide. What happened? Excess of hydrogen iodide. What happened? See, to form a OH, yes, with the Br to form a CH3Br. See, wait. See, here to form two products: ortho-bromo and para-bromo. Ortho-bromo and para-bromo. See, which is major? This is the major. Para-bromine, the excess of hydrogen added. What happened? So in excess of hydrogen halide to form a phenol with the methyl halide. Yes, methyl halide. Excess of H plus and X minus to form a phenol and methyl iodide. See, have a look for next question. See, benzene with OCH3 in order to find the A and B. What is the possibility of salt and alkyl halide? See, what is the salt? See, in presence of sodium phenoxide with benzene with NO2 and CH3X. X is in the form of X minus. Yes, the O minus attacks over on CH3 to form a product. So what is the second possibility? This is also one more possibility is there with the benzene with X plus NO2. So it happened. What happened? Resonances happen. When resonances happen, the negative charge is not attacks over on carbon. It is not possible. It is not possible. This is the possible. This is possible. Yes. I will look for next one. Benzene with OC2H5 H plus Br minus. What is the product? What is the product? So it undergoes what type of reaction? It undergoes SN2 type of reaction to form a phenol. First one is the phenol with C2H5 C2H5. Just wait. C2H5Br. Yes. I will look for next reaction. OC2H5 benzene concentrated HNO3 concentrated H2SO. What is A and B? See, nitration. Nitration happen to form a ortho product and para product. What is the electrophile? NO2. NO2. What is the product? Ortho and para product. Just para product. Yes. I will look for this question. See, concentrated hydrogen added heating A is formed and zinc heated. What happened? AB. See, I am taking if it is treated with H plus and H plus. So H plus attacks. See what happened. See, it is what happened. OH phenol. Okay. And what is the next? What is the next to forming? This is the iodine. So in presence of zinc is heated, what happened to form a benzene, to form a phenol and halide. It is treated with zinc heating to form a benzene. I will look for this one. Hydrogen iodide heating. What is the product? See, I will look for this. What happened here? O H plus attacks. It is a H plus. What happened? It is eliminated in the form of H2O. H2O is eliminated. H2O is eliminated. See, it formed carbocation. So here also what happened? SN2 will happen. Yes. So here also breaking of carbon and oxygen to forming phenol OH. Yes. Again it is treated with I minus. What happened? See. It is OH. Yes. This is the product. This is the product. It undergoes SN2 mechanism and CH3OH. CH3OH. See, this is the major product. This is the major product. Yes. This is a complete revision of ethers. Okay. So I hope like this video. Don't forget to share your friends. Don't forget to give the like. If you find content is valuable, make sure to subscribe our channel. Yes, hit the bell icon to stay updated videos and notifications. Thanks for watching.